Okay, I think it worked. I think we're live now. I would like to hope we are live now, and we're waiting just a couple minutes just to make sure everything is copacetic technologically speaking. Okay, all right, everybody. Thank you so much for joining us today. It's a very special day for us. We're here with our peers, with the brain trust of the industry from so many levels. We have our esteemed guests and distinguished panelists for this enlightening panel discussion where we aim to shed light on multifaceted issues and explore the nuances within the realm of cannabis extraction and the purity of the solvents used in these processes. As your moderator, me, it is my privilege to guide you through our conversation through a journey of insightful perspectives and viewpoints. Today, we gather not merely to scratch the surface, but to delve into the layers that define the intricacies of our industry. Unraveling those complexities and that often elude casual observation, we will talk with representatives from the refineries to the operators and everyone in between. Our distinguished panelists bring a wealth of experience and expertise, each contributing a unique brushstroke to the canvas of our discussion today. Together, we embark on a collective endeavor to deepen our understanding, challenge assumptions and hypotheses, and foster a discourse that our entire community can participate in. One of the main focuses of Hashbite is transparency and community, and bringing them both together under the auspice of this discussion is a great way to bring this to everyone. In the next hour or so, we will navigate through the contours of issues that operators and solvent suppliers are facing with the solvent supply chain, exploring its various dimensions and embracing the diversity of opinions that make this gathering so compelling. Before we get started, I would appreciate a moment of everyone's time in silence for all the lives, the innocence, the potentially genius minds that have been tragically lost. And we as Hashbite are firmly rooted in compassion, and we're on the side of love and peace and knowledge forever. And if we can just give me, 30 seconds of silence, I'd appreciate it, guys. Thank you guys so much for that. All right, now I want everyone's attention to our from our audience to our panelists. I want to start by one, letting them introduce themselves to the world here. So let's start at the begin. Let's start at the top. Andrew, I'll start with you, and we'll just go down the list.
Cool, awesome. Thanks, Simon. So my name's Andrew, CEO and founder of Extractor Depot. We've been around since 2016, providing equipment and supply solutions, primarily in the Southern California market. And we come from a extraction background, really understanding the hands-on processing and knowing the process hands-on. So we've gone from tapping cans of butane, open blasting to distilling 500-pound tanks of gas. So we've seen it all from the supply chain. So.
Sorry, Jane, please introduce yourself. This is the founder and CEO of Hashbite, ladies and gentlemen.
Hi, I'm Jane, Propane Jane. We wanted to put this panel together today to be able to, as Saman said, create transparency with our entire industry and the whole chain of custody. So thanks, everybody.
Amazing. Julia Bramante.
Hi, everyone. I'm Julia Bramante, and today I'm here just on behalf of myself So I've worked in the cannabis and analytical testing space for about 10 years now in various different capacities. Before that, I worked a bit in organic synthesis research as well as some molecular and immunological research. So most of my background and I guess insight I'm bringing today is from the testing side. I'm probably going to learn quite a bit from all of you about extraction and some of the challenges you encounter, and hope to have a good conversation. So thank you so much for having me.
Thank you so much for being with us today. Mr. Jeff Frick.
Hello, everybody. I'm Jeff Frick with Safe Gas Systems. We design and build compressed gas and cryogenic systems. And have for 5 generations and about 75 years in my family.
Thank you so much. We're honored to have you here, Jeff. Mr. Tyler Folino Graham.
Hi, I'm Tyler Folino Graham, also known as Sir Dabs a lot on Instagram. I work at Denver Dabco. I'm one of the lead lab managers. We do third-party processing, so I run nothing but the same material at work every day, you know. So we run from heavy metals to super fire, fresh frozen. We run everything. So definitely have a wide variety and knowledge and tons of extracts for sure. So
thank you so much, Tyler. Mr. Rami Rodriguez.
Hello, I'm Rami Rodriguez. I'm with Cortera Gas. We are in the production and manufacturing of your butane solvent, or Cortera Gas butane solvent, I should say.
Excellent. Thank you so much, Rami. Mr. Lex Shantz.
Hey everybody, my name is Lexus Shantz. I'm a lifelong cannabis activist and CEO and founder of Solvent Direct. We're a supply chain for extraction labs across the country, and I'm happy to be here. Thanks for hosting.
Thank you so much, Lex. Mr. Bill Loma.
Hey, it's Bill Loa, but I am with AdChem. I am the CEO, founder of AdChem. And we are very similar to a couple other people on here. We are a solvent supplier, dry ice manufacturer. I wanted to thank you guys, Jane and Saman specifically, for putting this together. I think it's going to, just push the industry forward if we can all be transparent and work together.
Bill, thank you so much, and I'm so sorry for that. I apologize.
Oh, good, man.
And I believe we have one more participant. Dr. R, is that you? Dr. R, if you could hear me, check and make sure you're not on mute. Perhaps. Okay. Well, it's okay. We'll get there. Hopefully he's there. And we will jump on into some questions here. But I just wanted to, again, just thank everybody, all of our participants, all of our panelists, all of the audience members that found the time to sit with us today and hear about some of these issues that are causing some questions with our operators, suppliers, refiners, and general consumers as well. So without further ado, let's jump into that. All right. So for our first question, and some of these questions are going to be targeted towards certain panelists on our panel. There's going to be questions that they're better served to answer than others. And so we're going to start with the majority of our panelists, which are in the supply chain, directly in the supply chain, from the refiners to the suppliers, and the experts that deal with those specialty gases. So, guys, this question is for Bill, Lex, Jeff, Frick, and Andrew. Please describe what you all think is the largest issue facing operators using LPG for their extraction solvent. And let's start that one off with Bill Loa.
Sure. Yeah. I mean, right now we're dealing with different issues. One being the Medusa stone. I mean, that's specifically for people making diamonds and shatter. But I think, supply chain, pricing, and the purity of the gas is what I would say are probably the main issues that extractors should worry about.
Okay, Lex, what do you have to say about that?
I think Bill kind of hit it on the head. I think the big thing is that we're dealing with like uncharted territory, right? This is an unprecedented application at a huge scale, and we're seeing, you know, everything from, you know, there's lawsuits against suppliers in the country right now for benzene contamination and other things that can cause cancer, and the lack of standards. That's I think the general tone is that. We just don't have a lot of precedent and a lot of standards to ensure safety and purity, and that's what we work towards every day.
Okay, Mr. Brick, what would you say?
I would say that I agree with the previous two comments, with the caveat that we, as an industry, do not treat this product like we do the rest of the specialty gas products. The supply chain does not apply the same quality control throughout it that we do with many other, with every other, not many other, with every other high purity gas. The cylinders are not treated the same way. And my background is in distribution. I now work on customer equipment more than selling the product. We install and commission analytical equipment to test these gases. We have set up production facilities at many of the distributors that fill in-house and distribute the product. And I believe that there is a lack of standards to follow, though there are a group of standard practices that are already inherent in the gas industry that have been neglected to be applied to this product.
Well, all right. Well, that's something we'll definitely come back to. Andrew, what do you have to say about what the biggest problems facing operators are that are using LPG as their extraction solvent?
I think a lot of the things that Bill said initially, I would agree with, and then also, a lot of us will swap tanks with each other, and there's a lot of probably contamination in tanks that are being, transferred in a sense between operators and whatnot. So it's really hard to trace where issues are coming from, and so I think that's part of the issue, and also how these cylinders are being cleaned, whether chemicals are being used to clean it, and being used in a carbon steel tank. There's these chemicals are definitely being left behind and being absorbed in the carbon steel makeup of the tank, and so I think that's one of the issues that people are facing too. So.
Okay, excellent. And on that topic of people sharing tanks or tanks coming back and swapping tanks, what do the suppliers do, and what do the refiners do? For that matter, is there anything that makes it all the way back to those refineries? Rami, can you chime in on that, please?
So, when we talk about refining product, it's more in the terms of fractionation. So we literally start with raw product out of the ground, fractionate that into its components, then purify and then process. So there's a lot of things in place, but once it's entering a cylinder, it becomes a lot more difficult, and we aren't as heavily involved in that. I love to participate in that conversation, but it's not entirely my place to say much about the cylinder maintenance. But I would agree with the comments. Specifically Jeff. I do believe that there's a lack of established operating procedures that are really paramount, considering this is a consumable. This is an LPG used in an application that's, still in its infancy. So, us personally at Cortera, we take that very seriously, and we kind of pride ourselves on being that bridge between old, antiquated oil and gas standards, and then, bridging that to the cannabis space. But, so I didn't answer your question, but I do think something needs to be done in terms of remediation of cylinders, and happy to look into that, but not exactly my place.
Totally awesome, and we appreciate you saying that. I didn't know if there was any, crossover, any overlap in that, so I appreciate you clearing that up for me and our audience. But that kind of leads us to our next question, which is, what efforts are the gas industry taking to ensure that a certain purity or level of purity of gas is reaching the operators who are using it in these processes for extracting product that will be inhaled or be consumed orally or something like that later down the road. Lex, do you have anything to add on that topic?
Yeah, I mean, and that's something that we are really passionate about. I think number one, to just step back to your last question, the chain of custody, right, from the manufacturer of the product, or whether it comes from the ground to the end user, is something to really analyze. We sell a lot of ethanol. Ethanol, when you look at food and beverage grade standards that have been well established for many, many years, there's a very clear chain of custody, right? So while somebody like Rami might be refining or fractionating the gas to a certain standard, and that standard is something that we should be talking about, but when you've got a manufacturer refining it to a certain standard, the question is, how does it get from that manufacturer to the end user? In the ethanol business, in the food and beverage grade ethanol business, there are many standards for, and we, for instance, the lines, when the bulk comes in from a manufacturer like Rami, you got to make sure that the lines are clean and that the lines are dedicated to a certain spec. The holding tanks that you're filling into, those need to meet a certain spec. If in the case of ethanol, like denatured ethanol, the industry uses a lot of that. There's mixing that goes into it. So now you're mixing two different things in a mixing tank. That's got to be to a certain standard. And then the container that you're filling into has to be at a certain standard. It's just like a restaurant with the dirty dishes. The coffee might be clean, but if you're refilling dirty mugs, you've got an issue. Industrial gas supply for 50 plus years has been refilling dirty, or you can't assume that they're dirty, but they're reused containers that have not had any cleaning standard done to them. Medical oxygen, there are some standards out there. But in the industrial LP gas, propane, butane, whatever it is, there aren't standards for that. And I think that's where you see a lot of these contaminants and variability and impurities introduced to the supply chain. Food and beverage grade ethanol is either filled into a food and beverage grade container, drum, tote, whatever it is, or it's filled into, and there are standards for reconditioning or cleaning ethanol containers, but they've got to meet a certain spec before you fill into them. And that's how you maintain a clean chain of custody across that product, so that the specification from the manufacturer to the end user is consistent. There's a huge opportunity here with gas supply that the industrial supply world just isn't familiar with. And so in 2018, to answer your last question, we started working with one of the biggest and most well-established privately held, family-owned businesses in the country that requalify cylinders. They're cylinder experts. There's about 5 of them in the country. They do all the DOT requalifications for cylinders for companies like Airgas and Praxair, the majors. They're cylinder experts. And that company is where we developed our 3-phase decontamination. And that's basically a process to clean every cylinder before every refill, certify it with a signature and a serial number so that you've got a clean chain of custody. And then we load those onto our online repository where you can search the serial number of any one of our tanks. And
will you buy me a charger for our phone and I'll pay you back?
Where you can pull up those certifications. So now you've got a clean spec on the gas that meets a certain standard from the certificate of analysis. And then you've got a clean certification of decontamination for the container. And by at least putting those two things together, we eliminate a lot of that variable contaminant.
Amazing. That was like such a great explanation, and you did a really good job of covering all those things. And it sounds like what it is there, from all of the panelists that I've heard in the last 5 minutes here, there are standards that exist. We just don't have them adhered to our industry or some form of those standards adhered. So that is it's good to know that there are standards. I know that there's nuances with our business and industry specifically that don't let that 100% kind of equate to what those standards are for other things. But that is exactly what we're looking for. We're looking for those standardizations so we don't have these issues that we're being faced with, right? So with that, how are analytical tests being performed on the cylinders or on the liquid that's coming out? And is there even any samples from the liquid being pulled, or is it all headspace? And I think this can go to the same people. I think we can also include Julia to the mix here, so she can kind of give an analytical perspective. And if Dr. Randy's with us, Dr. Randy, this is your moment. So why don't we talk about how gas is being tested? Julia, could you offer any insight into that for us?
Sure. Well, I'm not exactly certain or as familiar with what goes into the testing to certify gases exactly, but I can say there are a number of different tests that could help figure out what's potentially going on here. And I'm going to speak to a couple things, reminding everyone I'm pretty naive when it comes to the extraction workflows that you'll deal with. So feel free to jump in and let me know if I'm missing something. But what's coming to mind for me first is that it's always important to try to monitor and then control whatever step of the process you can. So it's great to hear that gas suppliers are coming up with some type of certification protocol to verify that the cylinders or dewars that they're distributing are in fact cleaned and pass some type of testing. I would say that for extractors or extraction companies, something that I would do, and maybe a lot of people have already done this or have been trying to do this, is of course you're testing your end product. I have some questions I might follow up on later about which products this is coming up in, or if it's kind of a mixture of everything. I know it's coming up in the THCA crystallization process, but I don't know if it's coming up otherwise. But really looking at all of the different critical points at which contamination could be introduced. So of course, testing the gas to make sure it appears clean. You bring up a good point. Testing it when it's vaporized is different than testing it in its liquid form. Something that comes to mind for me, and also looking at some of the tests that came from Dr. R, I believe, if I'm referring to that correctly, is that on NMR, it seemed like there was some type of oil, potentially, or mineral oil coming up in some of these samples. So that for me would beg the question, is that coming from the gas supply itself? If it were to be contaminated in the gas supply or in very minute amounts, it would be, I think, beneficial to take a sample of it in liquid form, evaporate it off, and then resuspend that in a smaller volume and try to test it via NMR or another method so that you're able to see it. So it's not limited by sensitivity. I would also look, though, to make sure things like plumbing are appropriate for the extraction process. So that's something we have to utilize a lot when we're thinking about setting up analytical instrumentation. But let's say you install metal tubing that has machining oil coated on it. Well, that over time will definitely start depositing into your extraction vessels. So that's another point of control that you could look at.
Yes, I mean, that's the benefit of using non-polar solvents is also to our detriment. So we we are only dealing with oils, and all the bad contaminants that come from the industrial processes are also oils. So thank you, Julia. That was so astute, so eloquently said. Thank you so much for that perspective. Jeff, what do you think about the current testing apparatus, the instrumentation used in the testing, and how the samples are collected from these processes for analysis? Is there anything that you see, or you could shed some light to give us a little insight on that?
It's a very wide variety depending upon what testing lab you're at, what gas production facility you're at. It's quite an array, if you will, from kind of 0 to 100 in terms of actually looking for the right things. Maybe not 0 to 100, maybe 0 to 75. The practice of making specialty gases, which this is, for me, this is just another gas application. the process of making them has been, established for, I don't know, many decades, back into the 40s or 50s, I guess, is when it started. And we, some of the things are left out with regard to cylinder preparation, with regard to post filling testing. There's not a specialty gas example other than this that I can think of where it's not tested after filling. Always, piece of advice, know what you're buying, know what your certification document is stating when you're buying solvents, and make sure they're testing for the right things. If all of the analytes are light hydrocarbons, you're missing a lot of constituents. And I believe the ASTM group is doing good work to identify some new constituents that haven't been part of the traditional high purity butane analytical regimen, and I think that's good. What's happening there, and that today though there isn't a standard for anyone to go by, other than I'm getting a lot of noise here from something.
Feedback.
Yeah, there we go. Sorry. No, it wasn't feedback. Just couldn't hear over the static. But there's not a good list of all the things that need to be tested for, I believe, and I believe that the biggest mistake that the industry is making is not testing after the cylinders are full. I don't, you can argue against that from all kinds of angles, but it comes down to you don't know what you have if you didn't test for it. And specialty gases, which the billing process of selling this particular chemical is in the specialty gas category. The pricing and the margins are specialty gas kinds of pricing, not industrial gas kinds of pricing. And if you're going to be charging for those kinds of things, you need to back it up with analytical work, not just on your raw material, but on the product after it's in the cylinder. And that goes for, what all of the potential contaminants might be. I've tested hundreds of these cylinders to figure out what the residues are and have a lot of information about that unfortunately I can't share with the world due to I don't own that information. I just perform the work, and there are a wide variety of things that have to be, added to the list that is being tested for that currently isn't being cleaned or tested, right? Because, again, as it's been said, this is a new application, and there's things going on that haven't been critical to previous specialty gas hydrocarbon applications. And so, my advice to anyone buying any hydrocarbon for extraction, having seen what I've seen on the insides of cylinders, is get analytical testing and get to know your gas supplier and what they're testing for, and don't just accept the cert for being 99.99 anything. Doesn't mean anything about what's in your cylinder. It's what are the impurities that are being tested for, and are they all light things that boil off at room temperature or not? Right? The samples have to be taken in liquid phase, and they need to be taken from the bottom of containers, and they need to be taken throughout the process from the tanker transfer to the guys making the stuff are making good product. It's the cylinder handling process and the filling process that is not. It's not done being perfected, and so just get to know your gas supplier and what are they testing for, and I'll leave it at that.
That's a great place to actually leave it, because the really the next, that kind of leads us to the next question, which similar, same team on speaking about this, but it sounds like to me that because we're not testing in the areas of the tank that we should be, namely the bottom of the tank, the liquid coming up from the dip tube, that a lot of this stuff could live there. So what do people do? Is it you just don't use all of the gas from your tank, or does it even matter? Can anyone speak to about that? I mean, if you're using from a liquid standpoint through a dip tube, is your first run contaminated or is it your last run? Bill, why don't you field that one first?
As far as a run, I mean, you'd have to probably talk to Tyler about that. But I mean, yeah, the dip tube needs to goes to the bottom of the tank, and so if the cylinder is contaminated or has mystery oil in it, it's gonna suck it up, and so you're gonna get it in your end product. A lot of people have to spend a lot of money to try and remediate it, if they even do remediate it. But yeah, I mean, I think what we're trying to do here is set the standard from A to Z, from supply chain all the way to the top to when the end user gets it. And there's different interior cylinder cleaning processes, I think, that different suppliers use. And we think that we use the correct one, the next person thinks they use the correct one, but there's no real standard for that, right? And so there should be some type of standard for that made. Kind of like Jeff alluded to, I agreed a lot with what he said. There's no real standard set because it's just infancy stages at this point, that we're in the industry, and that's why we're here, is to kind of set standards.
Awesome, thank you, Bill. And I know we just had Jack McCullough from Gas Innovations join us. Jack, can you hear me?
Yes, sir. Am I coming through?
You're coming through, my friend. Jack, I don't know if you heard the question or not, but we're talking about contamination, we're talking about testing, we're talking about standardization of these processes to ensure purity, cleanliness, efficacy, all those things. So the question currently is, if you're an operator and you have a tank of gas and let's just say, for all intents and purposes, there's a contamination there, when that operator is siphoning liquid from the bottom of that tank, are they going to get the contamination in that first run, or is it going to come in that last run, or is it just always coming out if the operator is using the liquid from the bottom of the tank?
Well, thank you for that, and sorry for the late arrival, guys. I just finished up with a late meeting, but I think where we can come in to help is, Gas Innovations kind of has grown up with the cannabis industry, and I'm, familiar with all the people on the call here. So hello, everyone. We've had a lot of offline discussions about these topics, but really how this boils down is three different areas. We have the gas purity itself and the testing. We have the procedures to fill cylinders, and then the analysis that everybody has mentioned on the call. So we've really taken that approach where we do test our gas. I think Jeff mentioned this. I get a certification from the refinery. Once it's in my bulk tank, I test it to verify, and then I batch test my cylinders after it's packaged throughout the day to verify. And that's very important to do. So, those are quality checks that need to be in place. How we have arranged our analysis is that we supply a lot of high purity applications in medical, electronics grade semiconductors, SpaceX. So we have these certifications and specs that are given to us. So essentially what we've done is combine all those. A great resource for this information is on Gas Innovation's website under extraction solvents. You can actually see what we're testing for. And we believe this is the most complete, comprehensive analysis being done. Like Jeff and a few others mentioned, we're heading up the ASTM committee, working towards this effort. But what I want to say is there's a lot of references going on about butane, and I just want to explain to the group that all butanes are not created equal. I think Rami mentioned it too. There's raw feedstock product, there's refined product, there's treated product, and it seems to be grouped into one. So we are very confident in our purity and our analytical capabilities, specifically for this market. Our processes and procedures do not salvage residual product. We drain any residual, pull full vacuums, inspect cylinders, and then again, we test throughout the day to monitor downstream processes. We feel that this is the best in place to do what everybody's talking about on the call, and that's monitor purity and your system. And so that's what we have done. One other thing I was listening kind of in the car right here is on the cylinder cleaning. as everybody knows, and like Lex said, definitely trying to push these efforts for the industry. Cylinders are manufactured. They have mill scale and particulate after the manufacturing process, and that's why we instituted a procedure to clean. And we do that initially on every cylinder. As far as re-cleaning after every fill, we do not have data to support that, and we'd rather keep it in dedicated service, keeping that cylinder safe from air and moisture and cleaning agents. And that's really kind of the standard. Sorry to hit you with a lot there, but that's really what we've done tailored to the cannabis industry.
Oh, that's great, Jack. Thank you so much. That was very astute, and I appreciate all the info. I was taking notes. Andrew, I want to touch back with you because one of the things you mentioned that I'm hearing and I want to address is the reusing of the cylinders or the swapping from customer to customer, and there might be remnants or not, and how those things are getting filled. Can you speak a little more on that with us, Andrew?
Right. So when you have a supplier, cleaning the tanks a certain way, that's different from maybe how your current supply chain is doing it, that could cause, cross contamination when you're putting that solvent that you're refilling that cylinder with solvent that, goes in that tank that's from another supplier. They might be cross contaminating with your batches and whatnot. So I think that's also happening. But at the end of the day, I think, there is no standard like we're saying. I don't think, that's going to take some time to be created for the industry. But I think it's really up to the extractor at the end of the day to have a standard in place for them from operator's perspective to always distill your gas. Since day one, I've always told, my clients, always distill your gas, regardless of who you buy your gas from, always distill, because I think that's the proper procedure to take. So I think a lot of times it's up to the operator as well to make sure they have a, standard as well for how they run their equipment, and make sure that, they're not just taking the supplier's word for it, but also doing their due diligence to make sure they're distilling their gas and doing their part to make sure the gas that they're using is as clean as possible.
Thank you, Andrew. That was actually one of the next questions, and I also just want to say that, I know that there is general consensus on these things. I know we don't have something, firm right now, but I know that's being worked on, and I know we're going to ask one of our panelists to kind of describe that process, what's happening currently. But the question is distilling your gas enough of a safeguard and enough of a measure to ensure your solvent cleanliness and purity and efficacy, or are you just contaminating your vessels and then extracting those impurities out of those same vessels later with the same gas? Lex, what about you? What can you speak on?
Sorry, I was tuned out there for just a second.
Oh, no worries. The question,
yeah, go ahead.
The question was, is distilling your gas enough of a safeguard for the average operator in the industry to ensure that they're operating with clean, unadulterated, uncontaminated gas?
Well, yeah. So when you're getting cylinders that are full of crazy impurities and contamination, you should at least distill it, if not more. That chain of custody, right? Back to the food and beverage grade ethanol example, that because there's so many wild impurities that we find in these cylinders, especially when there's not a cleaning process in place, you of course should be distilling it, because you got to get some of that out. But there are certain things that you can't distill. I mean, to my knowledge, you can't distill benzene out of gas. So some of the thick, the heavies that you pull out, you can pull some. I want to just touch back though. Jeff Frick mentioned there is random batch testing in place. We do it currently. It's very common in product liability. You can't test every can of Campbell's soup, but you can randomly test them. And having a protocol for random batch testing is very important in a product liability, from a product liability standpoint. So the idea that there's not random testing of individual cylinders, that is happening. You take a batch of 200, 500, whatever it is, you pull one and you test it so that you can verify that your standard is kept. Short dip tubes to hide mystery oil at the bottom of the tank is something we've seen for years. We offer a full-length angle cut dip tube so that you can confidently use every last drop. If you're currently extracting and your tank or your valve is spitting dry, but you feel liquid down there, it might be because the straw for your milkshake isn't long enough. And whoever that supplier is might be cutting that dip tube short to mask or hide things that might be sitting at the bottom of that tank. But yeah, the idea of distilling it, absolutely. If you look at GMP facilities, we supply a lot of GMP facilities here in the U.S. and abroad. They've got standards they have to test their solvent before they even introduce it. They have to go get their own independent analytical study. So the idea that a supplier just hands you a COA and you can trust it, forgive me, but it's kind of like a hooker with an STD test. I mean, are you really going to take her word for it or his word for it? I don't know. I would, and if you look at GMP standards, they have to, in some cases, independently verify the purity of that thing. So distilling it, sure. I mean, why not verify what you're working with before you introduce it to hundreds of thousands of dollars of product? The lawsuit, Mountain High Collective versus, I won't even name it, but you can look it up. It's in Washington. They distilled and they lost $600,000 worth of product, and it snowballed into a class action lawsuit. And the COA from that supplier said that it had less than 1 ppm benzene. Now, is that safe? Back to the standard conversation. That's something that we're working on at ASTM. Dr. Randy's actually on my speakerphone if he wants to jump in. But and Jack's involved with that. He is heading up that committee. But we've been for 2 years now. I've been working to set better standards with ASTM. If you're not familiar, D37 on cannabis, they encourage extractors, hands-on extractors, to get involved. You'll meet great people like Dr. R, who are seasoned experts, that can help with these things. But at ASTM, I first proposed the cylinder decontamination process. It's based on FDA CFR 2118 to 2194. There are standards, right? There are standards for cleaning oxygen tanks in between ventilators during pandemics. There are standards. We just need to apply them to LP gas. But in ASTM, what we all realized was that before you can determine whether or not a cleaning is effective or how to clean for this application, LP gas for extraction, you've got to determine what the standard is. And we've all been running around talking about instrument grade and ultra high purity. And then some people are trademarking terms like extraction grade and all this kind of stuff. But the reality is there is no scientific consensus on what the standard is for our consumers. And Jack has proposed a standard at ASTM, and I think that's out for debate right now because there are variables that I think, I don't know how much people want to disclose because a lot of people do want to cover their bases. Like I said, I'm a cannabis activist.
We're here as the community for gaining knowledge. So
sure. But I think there's a lot of information. I mean, I've seen tens of thousands of dollars in hush money paid out, right? I've seen this for a decade, right? I've been doing it since there were cans. I remember Bosco Kwan in Long Beach, the Korean guy that got, charged for selling cans of butane. I've seen this. And the reality is that, where we are at ASTM right now, everybody should join, everybody should get involved. But where we are right now is to determine how to clean a cylinder the right way to prevent these mystery oils from accumulating. That way you can give the customer a full-length angle cut dip tube, because a short one would be fraud under SEC. If that gallon of milk is off by 3%, you could have a stop sale put on that dairy.
Well, that's the net weight of the sale, which is the weight of the whole thing when it's sold.
Oh yeah, weights and measures. It's a big deal.
They're not getting the empty milk jug and testing the weight on that though. So
you guys mind if I jump in here real quick?
I do just want to say one thing, and I appreciate it, and I'm it's my job to kind of keep it going, but I'm gonna come back, and I promise you that Lex, I will let you finish that thought. But this does pose the next question, which is, look, when it comes to gas, we have the front end of that system, right? The supply. So the Ramis and the Jacks of the world that have a lot to do that. But what about reusing that gas? Can we talk for a minute about the gas itself and what's the lifespan of that gas being used? If we have terpenes that are in those vapor streams that are making it back to those tanks, are those contaminants corroding the inside of those carbon tanks? What other products and byproducts are staying with this stream of vapor that's coming in and out of these systems, from the suppliers to the operator system, to their tanks? So I do want to keep moving forward, but I do want to allow more time for these intricate conversations about these standards and everything like that. But I do want to talk about this solvent supply. So Jack, since you're leading in here, this is directly for you. Is talk to us about the efficacy of using this gas, the solvent, these hydrocarbons over and over again through these systems, through our organic plant matter. And what byproducts, if any, are they creating, or are they co-eluting with the gas?
Well, a couple things set that up, and I know we covered a lot, but there's no shelf life on the butane. We put it at 5 years out comfortably. As far as recapturing and reusing, that's kind of what we need to break into, and kind of based on what Lex was talking about. So, just to give you some more detail, we specialize in this testing and for high purity products. So, we have the spec created with GC and GC mass specs on site. We test for low oxygenates, benzene, just to kind of round up that it will help this answer. When we talk about impurities in the gas, there are people who are recapturing into the cylinder rather than using an ASTM operating tank. When you do that, you are putting unknown contaminants back into the cylinder unknowingly. Cannabis oils, potentially cannabinoids, terpenes, and any other contaminant that may be present in the system. So we do have to separate those two. The main issue with mystery oil we're seeing is people who are recapturing oils into the cylinder, and that'd be the cannabis extract itself. The initial cleaning we do is to remove mill scale and particulate from the manufacturing process. But as we all know, we use butane for a reason, because it's a great solvent. So if you have a cylinder wall, especially a porous carbon steel cylinder wall, submerged in butane, any oil is going to be leached out. That's not going to be taken care of by a cleaning agent cascading down a carbon steel cylinder wall. To answer that, what we provided the industry is an option for stainless steel, which may help, and we have cylinder manufacturers involved that have shown less residual oil. But we gotta separate those two, because if you're recapturing unknown contaminants, there is no telling what we're up against. And to say a cleaning process is up to speed to handle that, I can't agree with that. So we would recommend people don't recapture. That way we can keep it in dedicated service, and then that's how you maintain purity. When we talk about the distillation, Andrew mentioned that, and hey, Andrew, how you doing, man? What you're getting there is a distillation, as it's called by the industry, and I know it's changed recently, and people are actually using columns in their equipment. But for the most part, when people say distilling, they're talking about a passive distillation. So like Lex said, it may remove, when you do that, it's like a vapor transfer. It's going to remove particulates and heavies, but it's not going to remove benzene and other contaminants. So to answer your question from earlier, that's not going to ensure cleanliness of the gas. The short dip tube thing, I'm not seeing that. Things are not consolidating. And the proof of that we have is that we test our bulk tank many times a week, and there's no concentration levels of impurities increasing. So that's kind of where my role in this on ASTM, like Lex said, and the whole group who participates, is we're grouping everything into one where it needs to be separated. We take great care in the specialty gas products. There's a lot of touches on it, but that's what we do, and it's way different than a raw feedstock. And
So,
to Andrew's,
Jack, does mystery oil not come from gas supply? Are you saying that it's all marijuana that it comes from?
what I would say is if you're recapturing into the cylinder, particularly cannabis oils, carbon steel is going to absorb that. And from my
but
research,
ASTM just the other day, didn't you tell everybody that mystery oil is marijuana oil backflow? I thought that's what I heard you say.
no, I believe Randall provided Rami a sample, and he originally found cannabinoids and terpenes as that oil.
Well, Randy's here, and I think we're looking at the results.
Well, let's, the question before you go in there, Lex, let me just hold you 1 second, because the question was, are there terpenes that are making it into these tanks via the vapor stream of the collected, gas and whatever collection, whatever system you have?
And I would agree with that. Remember, guys, this is a liquid application. It's different from a vapor application, so you're actually using the liquid product.
Well,
we respect Randall's.
Yes, Jack, that's true, but you're also separating the gas via the boiling point of the butane. But what's happening in that collection process when you're doing that is that's co-eluted micella with terpenes and cannabinoids and everything else. So when you're heating that up to turn that liquid butane back to a vapor phase, to then capture it, recondense it, and separate it however you're rapidly expanding it or not. Are those terpenes getting with that vapor stream? Are they co-eluting that vapor stream, getting into your operating tank, supply tank, or however you're doing it there? But that's the question. So you're confirming that is happening, and we have confirmation of that. Is that true?
It depends, because your ASTM operating tank, or ASME, I'm sorry, operating tank is a stainless steel vessel, whereas this is carbon steel cylinder. So
some of them are carbon too.
What's that? In which case, I would say if you're using a carbon steel cylinder, being a porous material, there's definitely a potential for that to be absorb different contaminants that may not effectively be removed by a cleaning agent. We see that in many different applications. My recommendation, and again, you guys, Andrew, they can speak more on the extraction process than I can, but I would recommend not recapturing into your tank, and that's what we've seen has mitigated any kind of issues. A lot of the issues we hear are those people who are recapturing. Again, if you go on my website, you can see the internal scope pictures of what we've found, and that's going to be problematic. Okay. And that would be my determination on that.
Jack, thank you so much. Lex, please continue. And if you want to chime Dr. Andy in, please let us know. I could turn up your volume. I could try to turn it up all the way.
Yeah, I don't mean to filibuster this. Like I said, I'm super grateful that everybody's talking about it. In 2018, we introduced three-phase cylinder decontamination. This is from a company that's been requalifying cylinders for 65, 70 years in the business. They know what they're doing. They do oxygen, they do scuba, they do ventilators. They know how to clean a cylinder. And I think there's a lot of different opinions. I'll tell you, our customers are thrilled with the product that they get and the lack of shit that comes out when they distill their cylinders. I mean, it is what it is. And if you want to maintain a purity standard, you've got to be able to verify what's going on inside of it. I think the big thing that I was pointing out is that we do have a test result, a random test, that has this like through the roof, 1,000 ppm of mineral oil. And I think I'd leave it to the chemists to interpret that.
Let me bring that up for our guests so that we can actually view that. Give me just one
second. Let's note, while you bring it up, that is not currently something that's on the industry standard for high purity gas or instrument grade gas or extraction grade gas. I think, and if somebody wants to correct me if I'm wrong, this certain impurity that was detected at 1,000 ppm was not something that's on anybody's COAs. And so it brings you back to ASTM, and everybody really should get involved, especially hands-on extractors, because that's what ASTM wants. They want people with real practical experience. The issue is, though, that there was this variable that was 1,000 ppm, and it looks like some kind of oil is what I'm hearing. I'm not a chemist. I'm in transportation. I run 17 trucks around the country for extraction, dedicated to extract. But the point is, we need to agree on what impurities to test for. I mean, I hate to use sexual references, but an STD, right? You got to know what you're testing the patient for to determine whether or not they have high white blood cells or some kind of sexually, whatever it is. And right now, it's all over the place what people are testing for. They're just throwing around COAs, photocopying this and that. And so ASTM's focus right now, and Jack's heading it up, and he's got some great references on his website. But I think Jack didn't expect to see what was on that result. And that's because Jack's standard that he had proposed didn't test for this particular variable impurity. And what else? We don't know what we don't know. So while cleaning the dirty dishes, in my opinion, is just common sense, it's what restaurants do, it's what Solvent Direct does for extraction. But that's besides the point. I think right now we've got to figure out what is the standard. What are we looking for? And to what degree are we looking for it to ensure that it's not in the gas, and that is then therefore a safe standard. And I think also the scientists, again, could probably speak better than me, the method to arrive at that result, right? I think the method and the standard are equally important so that you can consistently arrive at the same result in order to determine what is safe and what's not safe. And I'm so eager to get there for extraction so we can stop hurting small businesses and people.
Thank you so much, Lex. I appreciate it. And don't worry, your next stop is Congress. So filibuster away, dude. You're good. Guys, okay, so I've added the NMR spectra from Dr. R. We have Julia here, who, you know, obviously Julia is very astute with analytical chemistry and can read one of these better than anyone, like in my family, at least right here. But I think we need Dr. Randy to give some context here. So if we can get him, Lex, and we could have him speak to what he was testing and a little bit more about what we're looking at with this spectra, this data, you know, outlook here, and what we're looking at, because then we can have a little more discourse around it. But right now, I think it's just a cool graph to us. So let's see where we go at that. But Rami, we haven't heard from you for a second, and you know we've had many discussions on standards and cleanliness, but the reality is we have this disconnect between the refineries and the operators, and we know that there's stuff that always going to slip through the cracks. So how are you guys at your refinery at Cortera? How are you guys, you know, mitigating any issue? How are you guys controlling the fractionation process, and then how are you storing? How are you transferring? Can you walk us through that, Rami, while we wait for
Yeah,
Dr.
absolutely. Yeah, honestly, I've been waiting for a good chance to talk. Can you hear me pretty well?
Yes, we got you.
Okay, great. So in terms of testing at our level, so we're testing, you know, I mean, a dozen times a day at every single step. We analyze, you know, we probably analyze too much, but that's just, you know, the world I come from. And so to answer the kind of question about analysis equipment and stuff like that, and liquid phase versus gas phase, we definitely analyze everything in liquid phase. We do composite sampling, we do spot sampling, and we run it through a variety of test methods and different instruments. So GC, GCMS, you know, it's so for the people that will follow kind of my thought on this. So we use a 100-meter plot column. We have an FID detector, FPD detector, and that covers your sulfur and your general composition. So something like that NMR that you're showing, I assume it's NMR. And so those types of heavy, you know, hydrocarbons, whether they're saturated hydrocarbons or unsaturated hydrocarbons, will still show up. You know, we're running a very long 45-minute analysis, ramping up to extreme temperatures. So it's not like a 0.1%, because if that's at 1,000 ppm, 0.1%, we would definitely identify that. And so, so just in terms of testing and stuff. So in terms of production, so we start with raw products. So literal crude oil, you can consider it, but really it's not crude oil. It's, you know, really in the more lighter phases, but that gets cut into the different fractions. That's where you'll get your C4 butane. That butane has to hit a certain spec, which is, you know, industry standard of 99.5%. And we always try to way overshoot that. And then post, fractionation, it'll then go into a series of vessels that are loosely called reactors. There's not necessarily a reaction occurring, but more chemical adsorbents. And so those take an already very refined pure product and remove trace levels of anything that may have gotten through as, you know, harmless as moisture, and then, you know, as serious as sulfur or aromatics. And so once it completes that step, it'll then go into storage. We have 30,000 gallon units. Those are analyzed every single day. Every single step of that process is analyzed. And before we even put it into a truck to send it out, we analyze that truck completely empty. It has to pass QA/QC. And then we analyze our bulkhead as it transfers the product into that truck. And then we pull a sample of that truck. And, you know, there's on the side of a truck, if you look at a truck emptying into a gas station, you know, there are these ports, a liquid side, a gas vapor side. And if you pull from the vapor line, you're pulling the top of that tanker. We like to pull from the liquid line because you're really pulling from the belly of the beast, as we call it. And you're getting whatever is at the bottom of that truck, you're pulling that out. And then we'll analyze that to compare it to the bulkhead, because there should be no difference between what we're producing and what's going to leave our facility. So hopefully that answers at least some of the questions. And then I think Randy can talk about kind of his data on that.
Yeah, no, we
I
appreciate
am worried
it.
I'm going to lose you, though, because I'm at 2%. And so I am a little worried. So I wanted to smash it out there just in case.
Thank you so much, Rami. If we lose you, thank you so much for being here, but try to stay on with us. So that was great. We love to know the processes, the procedures that each company is going through to ensure efficacy. However, obviously, we know that these are processes that are, operated with some degree of standard deviation. Now, what's happening on the other end of that is when, let's say, someone like Tyler gets this tank of gas and performs his process, and he finds these contaminants that interfere with his process. Those create issues. So, Tyler, please speak to us specifically about some of the contaminations that you've seen, that you've collected analytes for and have analyzed, and give us a little bit of an idea of the timeline, because I've been doing extractions for a long time, and we never really had a lot of issues. I mean, the oils, yes, that was always kind of something that we've seen, but there's a lot of discussions happening, a lot of discourse happening around other components that are in this gas, some potentially amines or something, that are interacting with the organic matter and creating a production method that isn't desirable from the operator perspective. So Tyler, please elucidate for us what issues you've encountered and what you've had to do to try to mitigate them, or are you still scratching your head?
Yeah. So mainly the biggest problem that we deal with is fast crashing, immediate sugaring directly after pour, or even sugaring inside the collection vessel. We do run all of our gas over activated alumina and 13X to try and mitigate some of this problem. We bought a PX1 solely for gas distillation. So the sample that I gave to Dr. Randy to have tested, we never have any cannabis or cannabinoids touch the system that we distill gas in. So everything that goes into that machine is coming straight out of the cylinders from the gas supplier. And then we, like they were saying, do the phase change of liquid to vapor and then recondense back as a liquid. And what I poured off after doing that it was roughly 500 pounds of butane, which we get 100-pound cylinders, 120-pound cylinders. So it took us all day probably to distill that. But by the end of the day, I squirted that out, and it acted almost identical to fast crash. I noticed when I capped the jar of the pour out, it stayed liquid. But as soon as I burped the jar or took off the lid whatsoever, it immediately changed to a solid and solidified. So that's the biggest problem we've had, is having fast crashing. But another problem we have had is a smell to gas. Had it with a couple suppliers, but it mainly smelled of mercaptans, which not too sure where that came from, but it definitely, the first time we had it, when I hadn't encountered it before, we had ran some plant material with the gas that had the smell to it, and the smell definitely carried over into our product. So we had to throw away probably 3 or 4 batches of product because we couldn't remediate out that smell any further. But what was that?
I have a question for you. Was it certain to be mercaptans, or could it have been sulfur from the plant matter?
So that's another thing. It could have been sulfur. The one thing I would say, the only reason why I pointed it towards mercaptans is because it smelled before using the plant material. So straight out of our distillation system, the pour outs from distillation, the jar was very pungent. Like you could honestly smell through the jar with the lid closed. So that was my only reason to point towards mercaptans, is because I hadn't introduced any plant material yet. But like people are saying, it could have been from cross contamination of something being in the tank beforehand before I used it, but I definitely noticed that the smell was there before touching plant material, but after touching plant material, it stayed with it. So the solvent itself was giving our hash a smell, which was not doable in our company for sure.
Yeah, well, I can imagine it wouldn't be. Jeff, could you speak to that? Would there ever, I mean, has there ever been an instance that in your so many years, I don't want to age you and tell how many decades you've been doing this, but has there ever been since you have been in this part of the industry with specialty gas for cannabis, that there has been mercaptans in any of the CP grade or any of the other grades for our extraction for mercaptans? Have you ever experienced that?
Yes, yeah,
Okay.
definitely. I mean, and I think those were let's call it cylinder mistakes by somebody who changed service inadvertently. Mercaptans are one of the worst things to get out of a cylinder. You're pretty much not going to. So
Okay.
if it's in there, you can scrub all day. You're not going to get rid of it.
Okay. Jack McCullough, is simple mistake, or is this something that's a fault, a faulty component in the supply chain and the refining chain, what have you?
Yeah, and I think Jeff nailed it. I mean, there are cylinders being changed in service. They're being used in cylinder fleets. And if they had been in odorized service, that is definitely going to transfer over. What I would say to that is just to also give some more background. We do millions of pounds of this for high purity applications like LNG, that, again, these are extremely tight specs. So I want to assure the group that we're doing that. We have implemented testing methods, and also including, to Tyler's comment, a low oxygenase test for alcohols, and that can contribute to odor. That's something that is possible. We have added that method to our standard, so we account for that. And I think Jeff nailed it. I mean, if you have a cylinder that was in a different service, that is definitely going to transfer over. So again, making sure you have a dedicated package in cannabis service is a way to mitigate that.
I will. Sorry to cut you off. I will add that I was hearing you guys speak about how the carbon tanks are more porous. I will say, at the time when we were dealing with the problem, they were stainless steel tanks. So our supplier went through the hassle of supplying stainless steel tanks for us, and it was still coming through. I don't know if that has any effect on how easy it would be to transfer the mercaptans. I'm sure, since he said they're pretty hard to deal with, it would be just as easy in a stainless as it is carbon. But
well, the carbon's going to absorb that more, but when we do our testing and analysis, that mercaptan and sulfur is definitely on our certification. That's something that is accounted for. We feel 100% confident to our method and what we have. Again, this is we've been in business for a long time, guys. 30-40 year vets on our team that man our laboratories. Multiple GCs and GC mass specs. Rami's been on site as well. He can attest to that. I would think it's more the cylinder package, but I, again, feel confident saying there's not a sulfur or mercaptan risk with this product.
Either
I
way,
have one question. Go ahead.
Either way, whoever put the gas in there didn't test it for all the things that it should have been tested for after they filled it, and that's.
And are you guys seeing the comments? We've got Cameron here reporting benzene from a stainless tank. You could use ruby tanks. I don't care if it's gold tanks. Maybe Trump has a gold tank. I mean, come on. This is about an industry and an opportunity that's going to happen once. And doing the right thing for our customers as distributors and suppliers, or for the end users that are consuming this stuff, it shouldn't even be a question. I mean,
Well, I don't think it is, Lex. And then what I'm saying is
you got a comment right here, Jack. Benzene in a stainless tank.
With no chain of custody and no sampling, Lex, I can't
Right.
copy on that.
Must be those marijuana people.
Not at all.
Well, let's say this. These thiols that are being placed into these into gas to notify people of a leak or a potential hazard. Okay, these are exactly the same composition, right, of certain flavorants and components from cannabis. So how do we distinguish? This is a Julia question. This is why Julia's here, guys.
I was just about to ask, is there something that could smell similar to mercaptans that is not a mercaptan that is being collected through cannabis or other components that's not being tested, and smells like a mercaptan but is not one?
One thing I'm going to add real quick to Lex's point, anything in 1,000 ppm we would see, that's definitely not showing up in what we're doing. One other thing I would say is the biomass spec, I would say, is not as tight as the butane spec. And I want to open this up to the group, and I've offered this to Randall and everybody else on the call. You are welcome to participate in our lab testing and send samples, and I will give you an analysis for that soon.
Jack, we don't even have to go that far, man. That's why we have the analytical chemists here, and that's why we're going to speak to that, because this is we're talking about using instruments that are that are going to go far below the sensitivity of just 1,000 ppm, which you guys use, which many other companies use, which Julia also has in her lab to test things. But Julia, if we're using GC with mass spec, and maybe just one mass spec isn't enough. Maybe we need to have a tandem mass spec instrument to test for these things. But how are these distinguishable? Could you distinguish a thiol from a flavorant compound from cannabis versus a mercaptan?
I guess the short answer is yes, but there's a lot that goes into it. This is really fascinating. I'm very appreciative to be here because I'm learning a lot from all of you about what you've been seeing. But no method is perfect for everything. And I think that's something really important to remember. And the scope and applicability of what you're trying to test and do dictates everything you do down the line from there. I also am seeing, I think, or inferring from a lot of the great questions and comments I'm seeing come in, that some people think this is some type of mineral oil or heavy hydrocarbon issue. Other people think it's more of a VOCs issue potentially. Maybe there's both things going on. Maybe it's more than that. But what I will say is that typically NMR is great for trying to look at whatever you may have in a sample. What's great about it is you see everything. What's also difficult about it is you see everything. And with that, NMR is not as sensitive typically as GC, FID, or GCMS. So that's something really important to keep in mind. So you won't be able to see low residues as easily, or sometimes not at all, using NMR. But there are ways around that depending on how you collect and then process your samples down the line from there. And so too, I think if the desire is to test for potential VOCs versus a mineral oil, I may have different recommendations for which type of instrument you would want to utilize to see if there's contaminants present. But it sounds like right now there's some degree of, I guess, exploration that needs to happen to figure out what contaminants are even a concern. I am not personally familiar with what mercaptans smell like. I've never smelled them myself. But something that came to my mind, and I have no idea if this is related or not, is that I'm not sure. I'm sure you've all seen that there was some research published a couple of years ago now, where they identified a new family of aromatic compounds other than terpenes called prenylated volatile sulfur compounds. And so I am curious if there's a possibility that there could be some type of reaction occurring with those that could be creating mercaptans. I don't know. But that's something that did come to my mind because that could contribute the sulfur that's being seen in the mercaptans.
Definitely, definitely. Julia, that was outstanding. And we are I'm more intrigued about what's to come after this from having all of these knowledgeable folks here. And I'm excited because we are going to be able to get down to, to a conclusion here at some point. It takes these conversations, it takes everyone's efforts and buy-in to get better and to raise the standard for our entire industry to be at the point where we're not questioning these things. And from an operator's perspective that deals exactly with these solvents and these processes, it's important to me, and it's important to so many others. We do have Dr. Randy available now, and so what I want to do is I want to quickly jump and show this this spectra, this graph here of the results from the analytes from one of Tyler's extracts. Now, this is an extract that extraction he performed where there was some mystery oils that came out and interacted with his product. They've collected that and have tested this. Now, Lex, I know
I will. So this is just a distillation pour off. So there is no plant material or anything interacting with it. So this is just results from a gas distillation.
Okay, thank you for correcting me on that. I appreciate that, Tyler. So just from the gas detection,
No worries.
there is no interaction with any organic plant matter. This is just the gas. So, Dr. Randy, can you hear me?
Yeah, I can hear you. Can you hear me?
Yes, if you could try to just speak as loud as possible, but we do hear you.
Okay, that NMR is the sample from Tyler's, and it's a great sample because it's essentially virgin butane. Now, while NMR is not a sensitive technique, it's possible to concentrate these residues that occur in the butane. So, for instance, if you take 100 grams of butane and let it vaporize, then a residue is left, and you can analyze that residue. So even though that residue is in a small concentration in the butane initially, the ability of NMR is that it can measure the chemical composition or help you determine the chemical composition of that residue. And besides Tyler's sample, I've analyzed several butane samples, and I find residue in all of the samples ranging from about 20 parts per million by mass up to hundreds of parts per million by mass. And the 20 parts per million is probably not concerning, but when you get into the hundreds of parts per million, then it's definite that residue is going to be deposited either in your THCA or from the extracts from your cannabis. So it is concerning. Now, can you hear me all right?
Yes, yes.
Okay, I did want to comment on the sulfur odor.
Yes.
Several people mentioned, the odorant that's used in, for instance, propane. They typically use ethyl mercaptan. But what can happen is ethyl mercaptan can react with itself and form ethyl disulfide. And that ethyl disulfide can react with ethyl mercaptan and form ethyl trisulfide. And you can actually form, they're called polysulfides. And they are less and less volatile as the chain length grows. But however, your nose is very sensitive. So even though the GC cannot separate those compounds or actually elute them from the GC column, your nose can smell that odor. So, I don't know for sure, but I think it's possible that some of the sulfur odor is from polysulfides. And with regard to GC, GCMS, those are great techniques, but they're not specifically designed for measuring heavy components in butane. They're typically geared toward the more volatile fractions of samples, samples that form vapors. And I think with regard to these residues, in many cases, those residues would become deposited in the injector of the GC and would not make it all of the way to the detector. So what people can do is take, a 100-gram sample and then let it evaporate in a test tube with a conical bottom, and then try to make some kind of observation of what that residue is in the bottom of that test tube, with a conical bottom. There is an ASTM standard. I don't have it in front of me now, but that standard could be used to help users determine or evaluate the residue in the butane. And then I did want to reiterate Lex's comment about encouraging users to become members or to participate at least in ASTM's committees, because I don't think that the users are being adequately represented in those committees. And your experience would be very helpful. You can participate in committees without actually joining, but even if you do join, it's a $75 per year annual fee, and it allows you to get access to all of the standards in D37, which is the Cannabis Committee.
With a signed supply agreement with Solvent Direct, we'll pay your membership.
Amazing.
We'll pay your membership. And Randy, I think it's ASTM D1835. Does that sound familiar?
Dr.
Yeah, it's ASTM D1835 is the existing standard.
Dr. Randy, question for you: is there ever an instance where these hold
on, Randy and Saman, you guys are talking over each other. Sorry.
Okay, I'm sorry. Can you hear me?
Yeah.
Can you hear me, Randy?
Yeah.
Okay, so the question was, I thank you for eloquently expressing this process and what's happening with these, isomers or these conversions of these of some of these chemicals. There is there ever an instance where these ethyl trisulfides or disulfides are converting into hydrogen sulfides?
It's possible, particularly if you had some kind of biological, bacterial contamination. And surprisingly, if you have a tank that contains hydrocarbons and you have a small water layer at the bottom of the tank, it's possible for bacteria to grow in that water and to actually consume some of the hydrocarbons. And bacteria love sulfur compounds, and they convert the sulfur compounds to hydrogen sulfide in a reducing environment. So that's definitely possible.
Wow.
So could I add to that we run facility microbial failing and mycotoxin failed, heavy metal remediated, like all sorts of stuff. So could the microbial remediated stuff, that organic matter or whatever you were saying, that the sulfur compounds?
I really couldn't say.
Julia, you might have a little more to say about that since you're a microbiological, expert. What would that be able to happen? Would there be any bacterial contamination that would hitchhike on this gas, on this vapor, and make it back into these tanks ever?
Still viable? I would highly doubt it. That would be surprising to me.
I would agree.
For sure, I've never tested it, but that would definitely not be my first hypothesis.
Okay, awesome. That was fantastic. I want to give a chance for Jack and Rami to also to talk about this, gentlemen, has there been testing on your end for these sulfides, even potential hydrogen sulfides, or do you have a test to test for that in the process?
Absolutely. So
Yes. Go ahead, Ronnie.
go ahead, Jack.
After you, sir. Sorry to interrupt.
Oh, you're good. So so we have two different labs. We have our on-site laboratory that we have, a very basic FPD, flame photometric detector, which will do a speciated sulfur analysis. So kind of tells you what sulfurs are present. But as far as those kind of more organic, sulfurs that could be found in biological material, the cannabis, we use what's called an ANTEC. It's a total sulfur analyzer. And so between those two, I feel very confident that we are seeing any and all sulfurs, including H2S, hydrogen sulfide. So that's just a short answer on that.
Okay, Mr. Jack.
Yeah, I agree with Rami there. We're taking these steps, and we sell a variety of different products, including hydrogen and nitrogens, methanes in the 6.0 range, and that's 6.9s. So we have methods in place and standards to account for even the smallest contaminants. But yes, that's accounted for. Again, going back to the recapturing comment, if you're recapturing from biomass or potential oils, again, unknown what could be potentially recaptured in that cylinder could also be a contributing factor. But like Rami said, short answer, we account for that. One thing I'd like to add too, and I'd spoken to Randall about this the other day. We would encourage that those samples be sent to us for analysis. Probably one of the most capable hydrocarbon testing labs in the country. And to Lex's comment, I just want to clarify, is we have some of the largest end user extractors in our office working with us, and we welcome that conversation. So we don't want to feel any extractor is left out. And to Randall's point, it'd be great if you guys join the ASTM call to contribute. But our doors are open, guys. So, we encourage you to use that. And we would encourage people to send these samples because in this discussion, we can weigh in, again, having this expertise.
Amazing. I also want to allow Jeff Frick a moment to speak on this. Jeff, I know you are very in tune with all of these. I mean, are we just going to see more, more tests coming down in the future? Are we going to actually, get into the process a little more and really understand where some of these problems are coming from, the etymology of the problem? Because to me, it's like, I'm pretty careful and I'm a pretty detail-oriented person, but stuff still slips through the cracks, guys. So how do we know as operators that we're receiving supply that's safe to use? And I understand that there's a case or two out there where it's something I mislabeled. It said non-odorized or not odorized, and it's odorized. But what's the frequency of that, and how are we able to understand what's being done as the gas industry moves to supplying more of this quality gas to us?
I hear every concern that I hear. I believe there are tests in place for, except for mineral oil, in most gas supply chains that do analysis on the product. So again, every one of those, there must not have been a cert for benzene on Tyler's gas. If there was, then that cert was complete bullshit. Okay, if there was, maybe it wasn't Tyler who had a benzene problem. Whoever had mentioned that earlier, sorry. Benzene is being tested for. The sulfurs are all being tested for by anybody that's reputable that's making the gas that I know of. So all of those things, the stink would have been caught. I will say that I've seen some pretty nasty terpenes come out of some cold traps on some distillation processes that are pretty sulfury, pretty fishy and sulfury. I don't even know what all kind of nasty smells they were that I've seen come out in some cold traps. And I believe there's something happening for sure there with residuals that get somehow extracted out of the system, either with a new solvent process or different raw material being processed. There is some stinky constituents that build up. I also think there's probably some sulfurs getting through because the supply chains aren't catching it for whatever reason. But if the cylinder is tested for, and it's tested for sulfur, and it's tested for benzene, which are two of the concerns I've heard tonight. It should be tested for moisture too. The comment about moisture, there should be moisture. It should be one of the things being tested for in every batch, if not every cylinder. And I mean, I have seen enough cylinder problems that I think every cylinder needs to be tested. I know everybody on here that's filling gas cylinders is going to throw a rock at me as soon as I'm done saying that. I've seen that enough that that's what I would want if I were using the gas myself, and that's what I really recommend. But I don't really see it going that way. I am the guy who doesn't have any gas for sale here, and I believe that just because of the mishandling that's already been happening. And so how do you weed it out? Right? I don't know how you get all these cylinders out of the field without something like that.
Well, you clean them, Jeff, and to your point, it's not the problem is that those COAs, the one that led to the class action lawsuit that's unfolding right now in Washington, was a situation where the COA read less than 1 ppm. The problem is that COA is coming from a bulk test, probably at somebody's facility, right?
That's not a valid COA in any specialty gas application other than cannabis for whoever that supplier was. Well, every other application, it's tested after it's filled. And
I beg to differ. Food and beverage grade ethanol, they don't test every drum.
We're not talking about ethanol. We're talking about gas.
We're talking about a chain of custody and the purity specification being tested across that chain of custody in a way that's sustainable for commerce. And it's been pointed out in ASTM that it is cost prohibitive to test every single cylinder that's being handed to a customer. That's why GMP facilities have to independently verify the purity of their solvent before they run it in their process. To rely on the solvent supplier for the solvent COA, it doesn't work, right? That's why in GMP spec you have to do it yourself. But what you're getting at is the filling of dirty cylinders. Right? If you take a bulk tank that tested for less than 1 ppm of benzene and fill it into a cylinder that was just returned to you by some other customer, and you have no verification of what's going on inside that cylinder or a standard for cleaning, like the dirty dishes in a restaurant, you have no way of knowing what's going to pop out of that tank. And if you read the lawsuit, the class action in Washington, the cylinder tested for 2.5 ppm benzene, but the supplier's certificate had less than 1 ppm benzene. Well, what could have happened in between that bulk tank test and the individual cylinder that tested for 2.5 ppm benzene?
All kinds of things.
Yeah, a lot of things.
That's where cylinder decontamination comes into play. And when you look at other industries that maintain
how do you validate your cylinder decontamination?
That's what I'm saying, Jeff. And let me piggyback on this real quick.
Would you like me to answer?
When you're Lex, you got
Could I answer?
Blue gold cleaning solution and cascading water down a cylinder is not going to remove mineral oils or other contaminants. So to Jeff's point, to verify you're taking care of.
Do you have data on that?
Let me finish real quick.
Would you share that data with us?
Would you? So what I'm saying is, if you're not cascading a cleaning agent down a cylinder wall is not going to remove contaminants. So saying it's decontaminated.
Do you have data on that? Because I have data that says otherwise, and FDA CFR 2118 to 2194 says otherwise.
I do have that data.
You haven't shared it with anybody at ASTM. Would you share it with us?
Gentlemen, I don't want to. I love this.
Well, a couple points. Let me finish if you don't mind, real quick.
Hold on once. I just want to say, look, we are reaching a time limit here. I do want to follow up with all of this because it's highly imperative to this conversation. However, we do need to validate what a cleaning method is that is viable and workable and all agreed on. But that's not going to be done here today, guys. So I'm going to say this because we need to, all these things need to be followed up on. But We are at an hour and a half. We can keep going here. It's not saying to stop. I just wanted to bring it back and say, look, if cleaning the tanks is the way forward, let's talk about that. Mr. McCullough, you say that, that's not a viable option to use a cleaning agent to clean the tanks. What is a viable option to clean the tanks and to ensure the efficacy of what the constituents in that tank? And Lex, I know you're going to speak, but I just want to say, like, if we say one thing doesn't work, what does work? And if there's nothing that works and we still need to develop that, that's a good answer too.
What I'd like to finish my thought if I could, and what we can do to answer your question is we can offer best practices. And what we recommend is keeping a cylinder in dedicated service as we account for it when we fill it by serial number. If you keep a tank in dedicated service, you can help mitigate this issue. A few things I just want to touch on that were said.
You don't sell to end users, Jack.
I do.
How are you verifying that serial number is going to the same customer repeatedly if you're not the end distributor?
I mean a cylinder in dedicated service itself. And just like we supply you.
So you send it up to like industrial source.
So I send it to you too, Lex.
I'm sorry, but how do you verify then that cylinder is going to the same customer over and over?
I can verify it's been in dedicated butane service is what I can do. Just like we do with your cylinders. Lex, if you don't mind, let me finish. Just like the cylinders we supply you and Andrew on this call, you know that our quality is good because we supply you those cylinders. The points I'm saying is I can verify a cylinder is in dedicated butane service. You are 100% correct. Managing it by serial number would be a very large undertaking, but I can verify it's in dedicated cylinder.
Don't mislead people then. You're not giving it to the same customer repeatedly, which is what you just proposed.
To that
I bought gas from you 2 years ago and I had lots of problems with it and I documented it and you never came back to me with data on it.
Lex, I can't speak to that because you haven't provided, but I'll push back just a little bit. Are you cleaning your cylinders with us?
Are you cool if I share the emails that I was sending you 2 years ago with those tanks?
That's not relevant to the conversation.
It's not at all. But Lex, I'll say this: Lex, are you cleaning your cylinders, all of them?
Every refill.
Okay, that's not true.
I certify it, and you can go to my website, solventdirect.com/documents, and you can go there and you can.
So that's not true just for the group and just and you can other comments here I'm going to make. If you want to project, this isn't a productive conversation.
All right, gentlemen, I appreciate you.
solventdirect.com/documents, Jack. Check it out.
Lex, I fill your cylinders. I know.
What I'd like to do, guys, at this point is I would like to say this. I feel like we need to compile the data and we need to come back and we need to, present some data. And I would love to hear from Jack. I'd love to have you do this. Lex, I'd love to have you do this. Rami, if you're listening, whoever else, we are open for this, but this has to be a discussion for next time because it is important, it is imperative. And Lex, everyone's going to go to your website and read up. Jack, if you want to point us to gasinnovations.com, if that's the web address, we'd love to read up. But this is exactly why we're here, guys. You guys are at the top of the food chain with the solvent supply per se. You're having those conversations. You guys are in the thick of it. We as the mere observers are here to learn, and we are being educated. But let's continue to educate here because that's what's important. Okay.
I have one more minute. If could I finish, and if not, it's okay.
I'll let you finish, but I just want to be clear, guys. We're here to educate the public here, so let's just do that. Thank you.
And then that's what I'm trying to do. Just a couple points here. The moisture comment Randall made is absolutely correct, and that may be also if you're cleaning the cylinder after each fill, popping the valve, there is particulate that's reintroduced, and also hitting the cylinder with moisture continuously can add to the degeneration of the carbon steel cylinder wall, and that could also be contributing. As it relates to benzene, we had extractors in our office, and as a response to the benzene concern, we lowered our detection limit from 1 to 0.1 and developed a new method to even go further down. To Jeff's point, it takes about an hour to test a cylinder with our low ox test as well. So you're right, the rock's thrown at you. That's going to be a hard thing to do, test every cylinder. And again, we supply most of the people on this phone call. So we're confident in our best practices and our procedures. I have data with cylinder manufacturers and our laboratories that I'd be glad to share. And again, just opening it up to the team. I'm here for you guys, and we are the experts.
We're going to follow up, Jack. Don't you? We're following up with this.
Let's do it. I welcome it, guys. I welcome.
I got a question. So earlier, Rami was saying that when doing testing, from the liquid port versus the vapor port. I've noticed when running and when we first start fresh tank, because we have to transfer from the cylinders downstairs up to our unit. So once we get stairs, basically, I've noticed that as I run with it throughout the day, the more and more that I off gas and some of the vapors, the more normal the gas is. What contaminant it may be is easily removed through off gassing, or I know a lot of other people when they are done or like close to recovery, they will let the last bit of gas recovering it, like everyone's saying, as bad practice. And that is because the contaminant is the vapor versus being poured out in the liquid. So I wonder, is there a possible way to test both from the liquid port and the vapor port and see it coming from the vapor side of things that you're not reading on the liquid port?
Interesting.
I think most SOPs that I've seen for this analytical methods for this, they include some tests from the headspace and some tests from the liquid phase.
Okay,
because
so
you're not going to have everything in either place.
Correct. We do both.
Gotcha.
And,
Gotcha.
we test liquid and vapor.
Okay, awesome.
Okay.
Awesome.
You know, another note too about the procedures is there are people who are top filling on gas. Just a note for the group here. This goes back to the three components here: the gas, the analysis, and the procedures. If you some people are getting a cylinder back with residual in it, and then they just hook up and fill right on top of that. Best practice, as recommended, would be to remove residual, pull a vacuum, and fill and certify. So that also may be a contributing factor. And I think what everybody's hearing here is there's a lot of variables, but from the gas side, we're confident, but we need your input. So I want to encourage that again.
Awesome. Thank you so much, Jack. Dr. Randy, welcome. Welcome to the show here. We're so glad to see your face and so glad you had time to join us. I can bring back up the spectra if you like, so we could discuss that a little bit.
Okay.
Okay.
I really appreciate the good job you're doing there.
Oh, I'm sure you know what? This is all for everybody. We're here for everybody. Knowledge is power, and you cannot break the community that we have here. All the people, all the viewers in our YouTube that are watching, that are commenting, these questions, these comments are absolutely amazing. I really wish we had more time, but what we're gonna do, we're gonna collect some of these questions. We're gonna do something, Jane and I, so we'll figure that out. But this is not the last of these types of discussions. I hope that everyone is willing to come back and join us. But I can't say enough about the quality of the people that are on this panel. I appreciate all of you so much. Andrew, I know we haven't talked to you a lot tonight. We're going to hear more from you, but we're really excited about you and everything you guys are doing and what everyone's doing. Just the level of knowledge has far surpassed my expectations, and I'm honored to be here with you all. Thank you. So Dr. Randy, let me bring this up here, and we can discuss this because it's important, and I do understand, and I want to just say that we do understand that testing the material coming out of these extractions is really important. Not just testing the distilled gas in these oils, but to test what's interfacing with our extract and what that means for our consumption. So that is something that we definitely are eager to find out as well. Obviously, with testing with NMR and certain compounds like THCA, there's issues because the only people that have those are universities. So we'll see what we can conjure up in the future. But for now, it's really good to know what's at least the mineral oil in the actual tanks. So Dr. Randy, can you please tell us a little more about the sample and your findings.
Yeah, so this sample is courtesy of Tyler and from Denver Dabs. And this sample never saw cannabis. So this is essentially a material from virgin butane. And it's the residue that was left over from the essentially distillation of a large volume of butane. And this spectra.
I'll add. So I'll add
Okay,
that
no, go ahead.
the gas was also passed over 13x and activated alumina, and then also 1 micron, 5 micron, and hydrophobic paper filter. So it was filtered heavily before I was able to pour out. So I just that it made quite a bit before still being poured out.
Yeah, I think what that highlights is that this residue is actually soluble in butane, in liquid butane. So it gets carried through filters because of its solubility, and that makes it difficult to remove. And I looked at other samples and saw similar residues, but also on other samples, I've seen residues that are different. So there's some diversity between samples. I've only looked at about 6 samples, but I'm seeing some consistency as well as some diversity, both in terms of what is there and in terms of the quantity. And as I mentioned before, I'm really not concerned with something that's in the low part per million level. But when you get into the hundreds of parts per million, it's somewhat concerning. I will volunteer to analyze anyone's butane sample if you could deliver it to me in a essentially 5-gallon cylinder. I can't handle anything larger than that because of the health and safety requirements that I have in my lab. But I'm in Colorado, I'm in Boulder, and so this area interests me very much. So I'm willing to comp some analyses for people.
Just the gas sample, right? Not anything with THC in it, right?
No, I can't handle THC either, unfortunately. But
okay.
I'm a fan of THCA and cannabinoid acids because my research is involved with cannabinoid acids. And another thing that Tyler showed me was some beautiful THCA crystals that are just gorgeous. They're like 100-carat crystals, and they're beautiful.
I have a quick question, Dr. Randall. Mm-hmm. So what NMR system do you have?
This is a Bruker Advance 300 megahertz.
300,
and we have 600 megahertz also. And this is proton NMR. I can do carbon 13 NMR. I can, but the 300 megahertz is a pretty standard workhorse instrument.
Yeah. Okay. And so can you walk me through your sample prep a little bit? Okay. It seems like you use deuterated chloroform to reconstitute, right? Okay.
Right.
Just reading that, but I'm curious. So what I'm hearing, and let me know if I'm wrong, Tyler, through the distillation process, I guess, distilled out some type of oily solid, and then you're taking that, reconstituting it, and testing it?
Yes. So okay. I took about 20 milligrams of that material. And so to address your question earlier about NMR not being a very sensitive technique, which is true, but we are essentially concentrating this impurity. And in fact, anybody can do this, get like a 50 milliliter conical test tube, pour about 50 milliliters of liquid butane into that test tube and then just let it evaporate. And you don't want to heat it up too much, otherwise it will, burp over. But if you let it evaporate, then you'll end up with a small residue at the bottom. And you can actually do an odor test, and you can do a visual inspection. You could even take a Kim wipe and wipe it at the bottom of that and look and see whether that Kim wipe exhibits any oily residue. And I think that's something that anyone could do without having any sophisticated equipment. If you want to get more sophisticated, you'll weigh the amount of butane that you add, and then weigh the residue that's left. And the way that I do that is I have a balance that's sufficient to weigh the container to 0.1 grams. And then, so I tear the container, and then I can actually concentrate hundreds of grams of butane. And then I tear the receiving vessel on a very 0.1 milligram balance. And so you can determine what the concentration of that residue is in parts per million.
Right. Right. Makes sense. And that's something I think it was before you were in or on the call, but we did mention briefly that you can evaporate off and concentrate things down to then reconstitute. But I do hear, I think I've been seeing some comments in the chat that there's concern that some of these might be contaminants that would volatilize off in that process.
Yeah, this is just for residue.
Right. Yeah.
So, things that vapor, like you would not do this for benzene for sure.
Right. Exactly. It's definitely a multifaceted problem.
But I think, the mystery oil, I mean, this is perfect for the mystery oil problem.
Yeah, definitely.
So
yeah, and
also really quick,
I also go ahead.
I just wanted to speak to specifically to this these results here, and kind of like, can you walk us through this, Dr. Randy? Like, are there 3 contaminants?
No, well, yeah. So this, I don't know if you can see my cursor. Can you see it?
No, I can't.
Okay. Well, let me start from the left-hand side. So as you go, you have a flat baseline, and then you get to about 7.2 something. There's a peak. That peak is actually from the deuterated chloroform. So that there's no significance. But but essentially everything between 0.5 and 1.5 is the CH stretch. And you can take this spectra, just Google NMR spectra of mineral oil and just compare this to what's available on Google, and it's almost a perfect match. But physically, Tyler will attest to this. If you take this residue and you wipe it on your fingers, it's kind of like a Vaseline. So, and it's
if you have oil on your hand, then oily and slippery.
Yeah.
Now, I don't want you to have to draw any conclusions, based on just sampling this, but would you conclude that this is something that's like in the process, in the refining process, or in the bottling process, or would you be able to determine where this contamination?
It could be. Well, ASTM, there are some methods out there for residues in LPG, and they say that the contamination usually comes from storage vessels or transfer lines or piping, and that's probably where it came from. I mean, it could be a compressor oil. If the butane was went through a pump that was oil-filled pump. That's possible. So it's really hard to say where it came from. And definitely with, just a handful of samples, you can't make too many conclusions.
Yeah. Mind if I jump and ask a quick question or make a statement real quick? So, with that, and I've contacted Randall offline and absolutely can furnish and provide those samples. We would ask that you send them to us as well. Like Randall just said, 7 samples is definitely not enough to do that. And having no chain of custody with that makes it very difficult. So let's give these dedicated, verified packages, which I'm going to send to Randall. I'd ask that you'd send me that sample as well of the oil so we can confirm and check that work. That would be my ask there. So
that's the sample that Rami had.
Okay. And so, anything that you could provide us to help verify, that's going to be helpful in this discussion. One other real quick, Andrew is
sorry, I didn't mean to interrupt you.
No problem. I will say I think it's important too, is Andrew on the call, who we supply, manufactures this equipment. And Andrew, could you speak to these issues? Are you seeing this?
We actually haven't really seen this Medusa issue as not as widespread as it's been discussed with our supply chain. I would say it's a lot of it is, I think, due to the chemicals that are used in the cleaning cylinder process. I just looked up, the SDS for blue gold, and there's chemicals in there that I would not want mixed with my solvents. And so
this is not a water soluble oil. This is mineral oil, meaning it's a hydrocarbon. It's not something that you would use as a cleaning agent.
How about on the oil side of things, Andrew, with the Medusa being separate?
I can't really speak on this part too much.
Okay. And what I just want to encourage the group is we have multiple discussions, and what makes it difficult from a supplier standpoint is that we furnish samples, things seem to work, and then as they run, there'll be an issue. And so there's a wide variety of variables that are at play here. And it's fair to say that we're interested in having that discussion, but we're not seeing consistency with that. So, for us, we need to be able to verify results and contribute to that, to add to this conversation. But again, we have product in the same lot that works fine. Some may have an issue. We refill the same lot. So that's what's making it hard from the supplier side. But again, I just think it's beneficial for us all to be involved. Again, being this is what we do day in and day out, we can weigh in on that. And I think that's valuable.
Jack, to be honest, I don't think that the methodology that you're following would detect this. So I think you need to do something similar to what I've done, which is collect liquid and then let it evaporate and analyze the residue.
And we have done that with Worthington Cylinders, who manufactures tens of thousands of cylinders a week. We actually conducted that same test. So we do have that data we can put together and share. And again, this is sample sizings in the tens of thousands of gallons. So we've done this in our bulk tanks and cylinders. And again, what I can do, and guys, Randall definitely has experience in testing, and Rami as well. John Garcia and Derek Berger, are our lab chemists, and I want to get them involved in this too with a written response, because they're, again, confident in their findings. So I'll try to put something together for the group and circulate that, and again, hope that's beneficial and it'll help with the conversation.
I say I will allow this only if Hashfight can show the data, and we can be the revealers of the data, just to have an independent, unbiased voice.
We're good with that, and we encourage it. And I want to calm it down again, guys. We love everybody on this call that we supply and we work with. We understand this is a new market, and people are trying to implement new procedures specific for cannabis. So we're all on the same page, but we just have to rely on the data that we have, the testing, and the experience we have. And so far, we haven't seen conclusive data to be able to draw such a conclusion, but we, again, encourage it. So these are tough conversations. We get it, but we want to be involved, and we want you to be involved as well. So absolutely, guys. I'm all for it.
They're certainly tough and certainly necessary conversations. Guys, with that, I just want to go ahead and wrap this up. We are approaching our second hour here, Mark, and I think that we did what we came to do, and we're just going to have to leave it here for now, but we will come back. We will do this again. We will provide some info for all of our viewers and for the community's sake. So I want to just give a very, very big thank you to all of our panelists here. You guys are incredible and the fabric of our industry, and we appreciate you immensely. I want to thank all of the viewers watching us on YouTube who have tuned in to check this out. I hope that you all gained some knowledge. I want to thank specifically everybody for interacting with us. The discourse in the comments was incredible. I want to send one more giant thank you to Jane and Hashfight for providing us a platform to have this discussion. And I want to thank everyone and their time. We appreciate you. We love you all. This is for the community. This is in the name of transparency and science and knowledge. Thank you. Peace and love to everyone. Thank you.